And welcome back. As we go ahead and now look at a different programming language, we had previously, of course, looked at Python. Now let's go ahead and transition to looking at C. So what exactly is C? Well, C is a general purpose programming language developed back in 1972, and it's still actually very popular. One of the main reasons why it's still so popular is because it's considered a fundamental language in the field of computer science. In fact, a lot of languages are based off of C, such as C++, C#, Java, etc. Now, C is very powerful. It's been used to develop operating systems, databases, applications, etc. And it's also very strongly associated with Unix, as it was developed primarily to help write the Unix operating system. So let's start by diving into some of the C syntax. So let's look at some C syntax through its Hello World program. You can see we have this hash includes studio.h in main, open close parentheses, bracket, printf, hello world, return 0. Now, one thing you'll note that's a little different here is we have this return 0. That return 0 is what actually indicates the end of our main function here. So let's also look at something that's a little bit new to us, which is this stdio or studio.h. The include statement here is saying include a header file library. And this is what lets us work with input and output functions and add functionality to our C programs. Don't worry right now, of course, about understanding how or really kind of what include studio is or how it works. Instead, just think of something that almost always is going to be within your program. And you'll notice that much of the syntax as we actually start looking at this is going to be very similar to what we've seen in other languages such as Java, though there'll be some slight differences maybe in how some of the implementation is carried. So let's start by first looking at how to print to the console. If we want to print to the console, we use the call printf. So printf, hello world. Again, not too dissimilar to some of the things that we've seen, for example, with Python or things that we've seen, for example, with Java. Again, very similar with some of that syntax. Now, one thing to note is that printf does not move to a new line of input. It is just like how we would have system.out.print in Java. All right, it's only one singular line of input. It doesn't actually have a carriage return on it to move to a new line. So if we want to insert a new line, we'd use a new line escape character /n. So if I did printf hello world /n, I am learning C /n and is awesome, return 0, is going to put hello world on the first line, I am learning on the next, and it is awesome on the third. Now, of course, we have other escape characters that we are familiar with that also carry over here in C, such as /t for tab, our // for including a / escape character, and of course /quote to actually put quotations in. Now, what about commenting? How does commenting work here? Well, to comment our code, we can use either single or block comments. Single line comments are, of course, just a // and multi-line comments are you having a /* or // to indicate the beginning and end of a comment. Now let's actually get into the meat of things here, looking at variables. First off, we have to understand with C, there's all the kind of basic primitive types we might expect. We have ints, which of course are going to store integers. We have floats, which are floating point numbers. We have doubles, which are longer floating point numbers. We have chars, which of course are single characters, and bool, which handles our true and false. Now, variables in C follow the same scheme as Java, so it's a type name equals a value with a semicolon. So, for example, I would say int num equals 3. It's going to operate the exact same way as we would normally be used to. Now, let's actually look at how to print those variables out to the screen, because there's going to be some things to note here that's going to make it a little different than what we might be used to. If you try to output the variables using the printf command, it will not display the value as we expected. So I say printf num, it's not going to necessarily just print out whatever value was in num. Instead, we need to specify first the format using the % followed by a character. So if I say like %d or mod d, if you want to think about it that way, that's used for ints, %f is for floats, and the % followed by c is used for chars. Again, we have to specify what that is going to be when we go to use that output. So let's look at this with an example to see how this actually ends up looking. So if we were to print some variables, let's say here I have an int called my num, I'm setting equal to 15, and I have my float num 5.99, and a character, my letter, is equal to d. Well, if I want to print those, you'll notice that when I put those in printf, it's whatever format it needs to be. So for example, the num is this % followed by d, and then I have a /n. The /n simply is just to, of course, display those on a new line. And what you'll notice is this comma my num. So it's not going to necessarily mean that we have to concatenate here, which is something we're used to. Instead, we're saying, hey, format this as a integer, and then add a new line. This one's saying format this as a float, and then do a new line. Format as a char, and then new line. So it's a little different than what we might be used to, where a lot of those more modern programming languages do allow this handling automatically for us, where we don't have to try and say, hey, this is an integer, this is a float, this is a double, because a lot of that's handled behind the scenes for us. Now, what about combining outputs? Well, if we want to, for example, combine, let's say, a text and a variable, we're going to separate them with a comma inside of the printf function. So if we have int my num equals 15, I can say my favorite number is mod d, comma, my num. So this is how we would do that concatenation of variables that we would normally use the plus operator for. So in Java, we say like, my favorite number is, end quote, plus my num. But here it's my favorite number is mod d, end quote, comma, my num. So a little different format that, again, than what we might be used to. Now, if we want to print different types within a printf function, we can do, for example, like the following. So here we have an int, we have a char. So here I can say the number is mod d, and my letter is mod c. So then I do comma, num, comma, letter. And so if you notice what it's doing, it's looking at each of these values here and corresponding it with the values that come after with each comma separator. Now, let's continue looking at how to update those values. So if we're looking at maybe just the variables themselves. If I want to update a variable, it's very simple, very straightforward to how we might expect them to behave. For example, I would simply assign a new value to a variable. I can just give it a new value. So anum equals 4, and then anum equals 10. Anum is now having the value of 10. Again, simple and straightforward. What about arithmetic operations? Well, these are the same as we would expect. Int num1 equals 1, comma num2 equals 2. Well, just do num1 plus num2. Obviously, if I want to store this in something like, for example, have it in another variable like num3, I can do that as well. But it's, again, going to operate very much like as we would expect. Now, what about the different operators that we have in C? Well, C has the following operators, which are everything that we are very familiar with already. We have addition, subtraction, multiplication, division, modulus, incrementers, decrementers. Again, all things that we're very familiar with, so these aren't anything too new. Now, let's do a quick note about Booleans, because how we are used to using Booleans in languages like Java or even Python to extent are a little different in C. If you tried, for example, to print a bool value, one thing you'll notice is that it doesn't display true or false, but rather 1 or 0. In this case, 1 represents a value being true, and 0 represents a value being false. Therefore, we have to use the mod d format specifier to print a Boolean value, because again, what's it returning? It's returning a 1 or 0, which of course are integer values. So if we create, let's say, some Boolean values, so bool is programming fun, set that to true, bool is fishy tasting, false, and if we were to print those, you see we have printf, mod d is programming fun. This is going to return 1, which means that's what's going to be actually displayed in the console. And our second statement is going to return 0, because, again, it's going to look for this flag here, which is false. All right, and for this lesson, we're actually going to look at an online compiler, because there is a little bit more nuance for setting up a C compiler than there is, for example, things like Python or C++ or C#. So we're actually going to go use an online one here, just so we can get used to learning it. And so this is a website called onlinegbd.com, and they have a free online compiler that we can use to test out our code. And one of the things is, if you first load up this page, you'll have kind of a default splash screen, and it won't have a language set. So please make sure that when you come in here, make sure you set your language to C. You can see we have all these different languages we can choose from. Again, we're going to leave ours to C, and I have some code in here that we can test out. Now, of course, you'll notice I start with our includes studio.h. We have to make sure it's in there. We have our int main, and of course, we have, because it's a int, we have to make sure we have a return type that matches that. So this is why we have a return 0. And then we, of course, are going to test this out. So let's go ahead and test it out with, we have here 2 different numeric types. And let's test out modifying that. So I have int num3 storing num1 plus num2. And we have our simple printf function here. So I have the value of num1 and num2 is mod d, comma num3. This, of course, is our format command right here telling us that that is an integer. So if I go ahead and run this, we get the value of num1 and num2 is 3. Let's go ahead and just do a little bit more in here. Let's just go ahead and add another printf function just so we can see this. What if I have the value of num3 as a float is, and let's just try to go ahead and format this as a float type. All right, and so what if I do that? Is that going to give us an error or anything like that? So let's go ahead and format that num3. I'm going to put that semicolon on there. Now, num3, if you remember, right now is an integer. So what is going to happen? Is it going to have, for example, some of that automatic conversion that we are used to seeing in other languages? Well, if we go ahead and hit run, all right, we get an error. All right, it says modf expects a type double, but argument is type int. So we don't have some of that automatic type conversion. So that's something that we would, of course, have to address if we were doing something. So this is very important that we keep this in mind. Now, if I had made this a double right here, and said, all right, well, what if we did this way? If I ran it this way, again, you can see we get a different thing here as well. It says it's expecting type int, and of course, we're getting 2 arguments of type out. So again, things to keep in mind here as you start getting to use some of these different format types. Because again, you're going to have to keep that in mind because you don't have some of that automatic conversion that you might be used to.